So whether everyone here knows how to write equation of a straight line and how to find slope of a straight line, those things are clear to all of you or not? If not, I will have to discuss those things also. So Santosh, Karthik, Abhinya. So equation of a line or what is slope of a line, those things are clear to everyone or not?
Yes, sir.
Like to everyone, no? You can write equation of a line and you can find slope of a line. Those things are clear to everyone. If not, tell me first. Santosh, Rishi, and I can't see everyone's name. Nishant, Karthik, Abhinya. Anyone having any trouble with writing equation of a straight line and things like that? If yes, tell me first.
No, sir.
Everyone is okay
Yes,
with
sir.
that, no?
Yes, sir.
Okay then. Okay then. Now we'll start with the differentiation directly. But proper way to talk about differentiation is after talking about limit. Considering everyone knows what his function is. So suppose if I write, see, you don't have to know how to find limit, but you must know what really we get upon finding limit of something. So maybe I will give an physical example, something that we can understand. Suppose if I have a regular polygon, and maybe I start with a triangle or equilateral triangle. Then if I make number of sides to become equal to 4, then I make number of sides to become equal to 5, then 6, then 7, then 8. And we know that it is totally possible to inscribe a regular polygon inside a circle. So this is some n-sided polygon having maybe some 9 or 10 or some number of sides. Now imagine if I make number of sides to become very, very large. So if number of sides, so maybe I'll write that thing as limit n tending to infinity. See this one, I wrote down as n arrow, then infinity. It is pronounced as n tending to infinity. So limit n tending to infinity, what will be a n-sided polygon is going to be called as a circle. If I say, is it correct or not correct? Correct, no? If I make number of sides to become infinite, then every side will become as tiny like a dot and they will be like at no separation from each other. Then what really it is going to give us, a circle or not? Correct. We started with a triangle, something which is a triangle inside a circle. Then we made a polygon or a square. Then I'm going to increase the number of sides to something more than that. Then if I keep on increasing the number of sides, you realize what really every side will be becoming equal to like a dot, no? So what will be that n-sided polygon is going to look like if I have n very, very big. It is going to look like a circle. All of you agree to this point? Correct? All of you agree to or not? Now, so if somewhere written limit x tending to a, f of x is equal to maybe b. It means how to find the limit of function of x, which is f of x. That is not something you have to worry about. But if somewhere written that this thing is equal to b, what really it means? It means if you provide an input to the function f of x, which is very, 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 very close to a, but not equal to a. Okay. So how much close to a? As much close to a you give, that is good. The more closer to the a, you provide more better. Then on providing such input which is not equal to a but very close to a, is at that particular input whatever the value the function is going to approach to, that is equal to b. So limit extending to, so this one is pronounced as extending to a. So limit extending to a, f of x means the value the function approaches when the input, that is x, is very close to a. So very is not like some correct technical word. So if I use the word infinitely big, you get the meaning. What really it means, something very big. So what can be antonym or opposite word? Antonym or opposite word of infinitely big will be. It is going to be infinitesimally small. So two things are infinitely far away from each other. You get the meaning. So what can be opposite to infinitely big or infinitely large is something which is infinitesimally small. So limit extending to, so this is called as limit. So in short form we write as LIM only. And this one is pronounced as extending to a. So limit extending to a, f of x means the value the function approaches when the input, that is x, is infinitesimally close to a. That is what really it means by limit extending to a f of x. And suppose that came out to be equal to b. How we found out b? Somehow we know that suppose it is b. Maybe God came and told me that limit of this function is b. So we don't worry about how we are finding the limit of anything. Just have to worry about what we get upon finding the limit of any function. That we are trying to find what is the value the function is becoming closer to or approaching to when the input is very near to a. So if limit of this function at x equals to a is b, it means when I give an input very close to a, the output the function will be giving is also going to be that much close to b. Okay. How to find the limit value? That is not something you will be ever doing for doing physics, but what is the limit is, that understanding is required. Okay. So how to find limit of any function? Maybe I'll take a very simple example, but before that, few things I have to tell. There's something we call it as trigonometric approximation. I hope you know what is meant by angle in radians, no? So we don't use degree system in doing science or proper maths. We use degree system only. So whatever the one full circle angle, which you were calling it as 360, will be called as 2 pi radians. So pi radians is equal to 180 degrees. Okay. So if I give you sine function, but be careful, the input given to the sine function is in radians. Okay. So limit x tending to 0, sine x. I'm stating this thing like a fact. Okay. I can answer why, but you don't worry about why. So limit x tending to 0, sine x is equal to x. But be careful, here x must be given to us in radians. Okay. So what happens whenever the input to sine function is very small, then output is same as input. One more thing you should know, like a fact. Limit x tending to 0, where x is in radians, cos x will be equal to 1. If I provide an input to the cos function, which is very near to 0, then output is approximately equal to 1. Limit x tending to 0, sin x will be same as x. Limit x tending to 0, tan x will be same as x. But be careful, x must be in radians. By default, every time, nothing mentioned, the angle given to every trigonometric functions in 11th, 12th classes at least will be in radians only. I hope whatever we have talked about in this slide, all of you have understood. So I'm stating it like a fact. I can tell the reason also, but I do not to complicate things, because the earlier we finish this basic maths, the more earlier we can start doing actual physics. So something not going to make you any good in physics, and something which is like pure math thing, not even remotely going to make you good in physics. Those things of maths will be told by math sir, and I'm not math sir. Okay, got the point now? I hope this is clear. Understood now, everyone? Okay, then now maybe I will take one example only, just the one example of how to find limit of a function. Even that much you should you don't know, you don't have to know for doing physics, but to understand from where the formulas of differentiation came from. Just for that understanding, I'm telling you all this, and maybe that understanding can be of use in developing your brain. That can be of use for doing physics. Okay. Suppose I give you one function whose name is f, and it is a function of x, and that is x square by x. And another function whose name is g, also a function of x, and that is x. So tell me, these two functions are same or different, first of all? These two functions are same or different?
Different.
Different, no? So there's something called domain. So thinking you should know what is domain is. Not like how to find domain of a function, but you should know what is the dictionary meaning of domain of a function is. Domain means all possible values of the input, all possible values of the input given to a function for which the output remains defined. So don't use, suppose in some maths exam, don't write the definition of domain like this, you will get 0, okay? I am telling some definitions which are not bookish ones, something which has to do with understanding only. So what are called as undefined values, or which are not defined values, are 0 by 0, infinity minus infinity, plus infinity by infinity, and minus infinity by infinity, and just one more, negative lying inside a root which is even root. What even root means? Square root, fourth root, sixth root, eighth root, and so on. So you tell me the domain of this function f of x, what it can be. You see, if I use x as 0, the answer of f of x will be 0 by 0, which is not defined. But except x being 0, at every place you will find f of x to be defined. So domain of this function is x. See, this symbol is a Greek symbol looking like some stylish E, but it is called as epsilon. And in maths, it is pronounced as belongs to. So x belongs to all real numbers except 0. But for g of x, it is not going to be getting undefined for any values of the x taken from our number line. The domain of this function is x belonging to all real numbers. So domain of this function x square by x, and domain of this function x are different, no? So these two functions are different. So this function f of x is not defined at all when x is 0. So asking for what is the output the function gives at x equals to 0 is not something which is going to make sense, because that is x equals to 0 is not among the values this function can take as an input. It's like going in MacD shop and asking for, give me a leather shoes. So they will say, man, this is not the place where we sell leather shoes. It is a place where we sell, maybe what is that called, burgers. Yeah. So there I will say, you're asking for something which is not defined. Same way, the output of this function is not defined at x equals to 0. So this function doesn't exist at x equals to 0. So if I ask you, find the limit of this function f of x when x is not 0 but very, very close to 0. So this is the only example I will take to tell you how to find limit of a function. So limit of this function f of x at x equals to 0 means the value the function will be approaching to when the input is very, very close to x. Because the value of the function at x equals to 0 asking such thing is not sensible thing to ask, because that function doesn't exist at x equals to 0. Okay. So limit x tending to 0 f of x means the value the function approaches, means the value the function is going to be closer to when the input is very, very close to x. Or another word or technical word for very, 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 so many very close to x is infinitesimally close to x. Now, maybe I can give some example. You can relate to that, but not a very good example, but maybe it will make sense. Suppose if I say x becoming 0 is like some analogous example. If x becoming 0 is death, like someone dying, means dead. And x being very, very close to 0 means someone undergoing or having near death experience. Like that guy went very, very close to death. Maybe for 1 2 seconds his heart stopped. And then was revived after that. So don't you think that someone literally dead and someone undergoing near death experience or not same thing? No, they are like very different. Same way, x is not becoming 0. X is going to be getting as close to 0 as much possible, but not becoming 0. Becoming 0 is dead, and being very, very close to 0 is like near death experience, like kiss of death. Got the point, no? So how to find limit of something, that is one thing, and what limit is giving us this thing. How to find limit? Not in our physics thing. The value the function approaches when the input is infinitesimally close to x. So I'm telling an algorithm, the one which is used to find limit of any function. Why that algorithm and why that algorithm works, those things is a discussion of math class. I'm telling we have got an algorithm, and following that algorithm is going to give us this thing. What thing? The value the function approaches when the input is very, very close to x. So if you don't understand how to find limit of any function, don't worry, you don't have to understand. If in LHS I write limit extending to 0 f of x equal to maybe something. So whatever that something written in LHS, what really that something means to us, that is the only thing you must understand. Now the algorithm part. So limit x tending to 0. See, I'm telling it orally because you don't have to know this thing, how to find limit of any function. So tell me, right now, what is the process is I'm telling you, the algorithm. So here the limit value is what? X being 0. You plug x as 0. So every time in any question of limit, what is the first thing you will do? The limit value, which is 0 here, you plug it in the function and then check what answer comes. So on plugging the limit value, you will realize we get 0 square by 0, which is 0 by 0, which is what? Defined or undefined? So you cannot make sense of this number, no, and 0 by 0. So that is like something which is undefined. Now, so if I get something undefined, means we have to solve. What solving? Nothing difficult. Something which is very simple. After every solving or simplification, you will again and again you will plug the limit value to check what answer we get. If the answer comes defined, you stop. Maybe I'll write a flow chart for that. So decision, to take decision, we use this triangle thing now, man. Plug limit value in the function, and if you get defined answer, then no problem, that is the answer. If you get undefined answer, you get an undefined answer, then you do some solving, and after solving you again check the limit value, then you get defined answer, that is the answer. Not defined answer, you solve again. So you will keep on doing this thing as long as you don't see a defined answer, or as long as you could solve it or you could simplify it. And even after full simplification, whatever possible, you don't see a defined answer, no problem. The limit of something can come undefined also. So here it is easy. So we have limit x tending to 0, x square by x. So the numerator thing I will write down as x into x. It is totally legal thing to do from maths point of view, no? From mathematics point of view, it is a legal thing to do. And what mathematics tells us that, and also we know the x in numerator and denominator are not something which is 0, correct? If 0 means not defined, it is something very small. Small, so what? The rules of math is same for small or big things. Just because someone rich, so rules will not be different for him. So someone small, rules will not be different for him. What rule of mathematics tells us that something if identical in numerator and denominator, then we can cancel them. So we cancel them. That is the simplification I was talking about. After every simplification, you plug the limit value. After this simplification, we get limit extending to 0. I plug the limit value, what I get? 0. So 0 is defined. Yeah, totally defined. Something that is there on number line is defined thing. So defined means that is our final answer. So limit of this function f of x at x tending to 0 is 0. What it means? It means when input is very, very close to 0, what is the word for very, very close? When input is infinitesimally close to 0, then output is also very, very close to 0, or I will write the output approaches 0. So how limit x tending to 0, f of x is 0? We don't have to know that. But somewhere if I write limit x tending to 0, f of x is 0, then you must understand that RHS of this thing is 0. It means when I give an input which is very near to 0, this function gives an output which is also very near to 0. How we got limit of this function as 0? That steps you don't know, you don't have to know. Okay. So whatever done on this slide, is it clear to everyone or not? See, another way is also there to teach differentiation. Like differentiation is a mathematical tool which will give me this and etc. etc. So it's like telling you to mug up things. But you're not neat students, man. You must understand from where all these things came from, because in future anyhow for doing maths you have to understand all this. You can't skip any of this thing even for CBSE level maths. Okay. Okay. Anyone having any doubt in here? If yes, I'll give a minute to digest whatever I've told. Then I will take a new page. I'm taking a difficult path to understand differentiation. And difficult path most of the time is correct path. If easiest paths are cheating things, cheating things will not give you a good rank. Okay. Generally difficult path, easy path to attain something will not be a correct path. If you find your path very easy, means you're doing something wrong. Things are not going to be easy. So Chanakya told that if you see your path is very easy, then your path is wrong. And that works in everything, man. Path, easy path. If you see your class is very easy, you can understand everything. Means teacher not good. He is not teaching properly. That it is he is not teaching properly the way that should challenge your brain. So that kind of coaching you leave straight away. Easy, easy, you're understanding everything, not good coaching, cheating happening there. If your brain hurts in a class, then class is good. When okay, all of you understood this, the limit thing? What do you have to understand? If I write down this thing, that much only you have to understand. If somewhere you find this thing written, means you how to find that limit of x tending to a became b, not required. But this statement written somewhere, this equation written somewhere, you must understand the meaning of it at least. That it means if the input is very, very close to a, then the output of the function will be also very, very close to b. So that much you understand. How to find limit, you don't understand, you don't have to. So anyone having any doubt? If doubt, I'll explain again. These are limit things. Could be confusing today, I tell, tomorrow you will understand maybe. And this is below CBSE level maths, man. I'm not touching even 10% of CBSE level maths. Not even 10%. Not JE, not NEET. CBSE level maths. Okay. Anyone having any doubt? Santosh, Rishi, Rakartik, Abhinya,
No, sir.
Nishant, all of you understood, no?
Yes.
Okay, then. I can take a new page now. I can take a new page.
Yes,
Yes,
sir.
yes, sir.
Okay, then. Now, suppose if I have graph of a function or plot of a function which is not a straight line, and everyone told you know what is a straight line is and how to find slope of a straight line, things like that. And if I have a curve which is really a curved line, the curve does not mean that it should be a curved line always. No, it means graph of some function is called as curve. Plot, another name is curve. So if I have a function y equals f of x, which is a curve, and if I ask you find the slope of this curve at any point, maybe here, where x is maybe x naught. So what we do, at that place, we drop a tangent to the curve. And the slope of the tangent to the curve at that place gives us slope of the curve at that point. So slope of a curve is equal to slope of the tangent to the curve at that point. And how to find slope of a curve, which is a straight line? So one way, maybe just for safety purpose, I'll tell fast. So it depends what you know regarding that line. In case, if I know the angle theta the straight line is having with positive x-axis, then slope of that straight line will be tan of angle theta, where theta is angle made with positive x direction. So that is one way to find the slope of a line. What is the another way? In case if I tell you 2 points which are lying on the straight line, and those are x1, x2. At x1, the y coordinate is y1. At x2, the y coordinate is y2. So what we do in such case, that construction maybe you should know. So we draw a horizontal line through one point, maybe this is A, and a vertical line through the another point, which is B. And that is going to give us this triangle ABC. And I hope all of you can find how much is AC. That AC will be x2 minus x1, and BC will be y2 minus y1. And in that triangle ABC, this angle will be theta again. So I can use that triangle to find tan theta, which is the slope of this line, which will be BC by AC. That is going to be y2 minus y1 by x2 minus x1. Okay. And that can be also written as delta y by delta x. So this triangle symbol here is called as delta also. So if somewhere I write delta y, it means a kind of change in the quantity y, which is finite. What finite means? Which is not infinitesimally small. And what infinitesimally small means? Something which is as small like atom or virus that you can't see with naked eye. But if something is 2 centimeter, 3 centimeter length, the one which you can see with naked eye, such kind of thing will be called as finite. The thing that can be measured using normal ruler maybe will be called as finite. So delta y means, so whenever we use this delta symbol, this triangle looking symbol, we are finding change in that quantity. So delta y means finite change in whatever this variable y. Suppose if I write delta capital T, where T is temperature, then that means finite change in the temperature T. So what is delta y? Finite change in y. And what is y here? Output, no? Finite change in output by finite change in input. So I hope So it now, if I know 2 points lying on a straight line, this is the thing I will use to find the slope. In case if I know the angle theta directly, no problem. Directly I will find tan of theta to find the slope. So whatever on this slide is known to everyone, or you have understood it at least now. If you, I'll give a minute, no, not minute, 30 seconds. You can take a new page.
One minute, sir.
Okay, no problem. Just a second, man. I have to pick this call. Give me a minute also. Hello, class, man. Hello. One second. Okay, I will take a new page now. Suppose here I have a function y which is a function of x, and this is the graph of this is the graph of the function of x. Now I'm going to select a point, suppose A. There the value of the x can be anything, maybe 2 or 3, but in general we are doing it, so we consider the value of the x to be x here. Now I'm going to introduce a change in the x. So whenever I write change in any quantity, and if that change is finite, we write like this. The delta x will be final x minus initial x now. So what will be final x from this thing will be equal to initial x plus delta x, which is the change in the x. And initial x I write down as x only. So we get final x as x plus delta x. So we are going to change x by some finite amount, giving us another point where the x coordinate is x plus delta x. So maybe just some tiny things. If I give you maybe f of x is x square. These are some notations, nothing conceptual here. If I write f in bracket 3, what you understand? 3 square, no? So f of 3 means the value of function when x equals to 3, correct? Which is 9, depending upon what function it is. So, but only f of 3 written, you understand what it means. The value of the function when x is 3. So same way here, when the input is x, the output will be whatever the value the function will have when input is x. Next, I am changing the input by finite amount, making it equal to x plus delta x. There the output will be whatever the value the function gets to have when input is x plus delta x. So this I can call it as maybe initial y, because this I'm calling it as initial x, and this I'm calling it as final x. Same way, I can call the y values there as initial y and initial x. Now, what is the next thing we are going to do is to draw a line, and this red line, which is supposed to be passing through the point A and B, both of them. So let me draw it once. So now this line, this red one is a line passing through A and B, both the points, no? Intersecting the curve at B and point A. And that line cuts the curve or intersects the curve at two places. What is the name of such line is secant. And if the curve is a circle, then the name of that line is chord. Okay. So secant or chord, both can be used maybe. So this angle is making an angle theta with the positive x. So similar thing I will do. I will draw a horizontal line through A and a vertical line through B, giving us this triangle ABC. And this triangle ABC, this angle is theta. again, no? But what is this length AC is? Totally you can tell that length is the input, the difference in the input we have done, which is delta x. And what is BC? That is f of x plus delta x minus of f of x, which is basically the change in the y or the output when we have done delta x change in the input, which is x. So whatever done till now, is it clear to everyone? Because after this, things can get confusing. So up till here, it is totally clear to everyone or not? One more point I will write. So slope of the chord or secant AB, by that I mean the secant which is passing through the point A and B, will be equal to tan of this angle theta. But we use this triangle ABC to find the tan of this angle theta. So slope of secant AB, you understand, no? Slope of secant AB means slope of the secant which is passing through A and B. So slope of secant AB is going to be tan of the angle theta it is making with positive x direction, whose value will be same as BC by AC. What BC is f of x plus delta x, and what AC is delta x, no? So BC is f of x plus delta x minus f of x. AC is delta x. So up whatever done till here, is it clear to everyone? I'll give a like few seconds to digest all of this thing. Just tell me, anyone. Once an understanding or copying, you tell me, I will take a new page.
Yes, sir.
Tell me, tell me. Understood, no? Or any doubt?
Yes.
Any doubt? I want to check the mic quality. Do you hear any background noise like that? No, no? Nothing, no? Then good. Okay, 1 minute you are asking, okay. No problem, I'll give you time to copy if you want to copy. Anyone having any doubt? Abhinya, Rishi, Santosh, Miss Nishant?
No, sir.
Okay, okay, then good. Okay, then next thing is, in case if you have not copied it, tell me, I will come back to this page again. So what is differentiation or derivative of any function? See, all these things are synonym. Differentiation, finding derivative, or finding rate of change of any function. So here y equals f of x. Then there's something which is called as dy by dx. And what it is equal to is limit x tending to 0, delta x tending to 0, f of x plus delta x minus of f of x pi delta x. And I live in KK Nagar, near to that. Still feels like Saudi Arabia it is. India is changing like anything. 5 times full noise, they will disturb everyone. I complained also, but no one listens, man. I complained in police station also, but nothing happened. And it is against Supreme Court rules also that you cannot produce sound at such high decibels that will make elders and children to wake up at 4:45 a.m. Really feels like we are living in slave country or something. So we're coming to whenever it comes now, it makes my mood bad because I complained and nothing happened to it, man. I pay so much income tax, more than these people maybe, and no one cares about people paying income tax. Okay, now the thing is, we will do a thought experiment. What is the thought experiment is? So now, just how I'll draw it first. This is the only difficult part. If this one you understand, after that everything is algorithmic, formula based, nothing to understand simple things. But this understanding required, man. Suppose if I consider this x point, the point A to be fixed, I'm not changing this point. Okay. And what I'm doing is I'm decreasing the delta x. I'm decreasing the gap, the horizontal gap between point A and B, delta x. So earlier we started with some
Sir,
delta.
I can't hear your voice, sir.
You can't hear me? It's mute or what? No, it's not mute. You cannot hear me. Everyone else can hear me, no?
Yes, sir.
So maybe some problem with your thing. You have to rejoin back again, man. So tell me, earlier this is point A and this is point B. Now I am decreasing the delta x while keeping x same. So next, so difficult thing to draw, man. Now this is the original point A, which is fixed. And this is the original point B, which is not fixed. Now if I decrease delta x, keeping A same, then the next secant for slightly decreased delta x will intersect the curve at B here, no? Then further I decrease it. It will end up intersecting the curve maybe here. Further I decrease it. It might intersect the curve here. Further I decrease it. It will intersect the curve here. Then I keep on decreasing delta x so that there comes a moment that delta x became so small that it's not visible to you with your naked eyes. Maybe you need microscope or something to tell t cap whatever delta x is. Then in such case, when delta x becomes so tiny, like a virus or atom kind of tiny. So in that case, what is the point A and B will be? If delta x becomes very close, the point A and B, don't you think will become almost 1 point? Not 1, but almost 1. I hope all of you agree to this statement. See, earlier, this red line was the secant to the curve. Now I decrease delta x, this black line is the secant of the curve. Then I keep on decreasing to an extent that delta x is nearing to 0. So in that case, maybe I'll draw some other color. when delta x is nearing to 0, A and B will become almost 1 point, and that secant, which was supposed to pass through both the points A and B, but A and B are not like two different points now. They're almost 1 point. Then that secant will look like this violet line or not? Because it has to pass through A and B both, but A and B are not two separate points. It has become almost 1 point. Then instead of cutting the curve at two places, the line will end up touching the curve at A only. So that line, which was secant to the curve, what is its nature has become now? Tangent or not? Tangent or not? Anyone? So under the circumstance, when delta x is becoming very, very small, point A and B will become almost 1 point. Then that secant AB is going to be becoming tangent to the curve at point A or not? So this is the only thing you have to understand. After that, nothing to understand, just an algorithmic thing that you have to do. This is the only thing you have to understand, even for maths, not like if I don't tell this thing, you can skip this thing. No. Forget about JE or something. Any field you go, maybe tomorrow you took commerce and did maybe CA, chartered accountant, still you have to know this thing. So except maybe dancing, singing career, even singing, maybe science of singing, there also calculus, you can't live without that. So there also some science is there, maybe. To tell me whatever is written on this screen, all of you have understood or not. I'll give a moment to digest whatever I've talked about. Anyone? Having any doubt? Till here? Reply no, and otherwise it feels like radio jockey, man. That's why I hate online class. But I don't have a choice. All of you understood, no?
Yes, sir.
Okay then. So now, this expression was giving us the slope of the line which was passing through the point A and B. But if I consider the condition when delta x is very, very small, then the nature of that line will become different, no? Like whatever it was earlier, which was secant, now under the condition when delta x very, very small, it is going to become a tangent. So now if I write limit delta x tending to 0, this expression we understood was giving us slope of the line which was passing through A and B, and that was secant. But if I find the value of this expression under the circumstance when delta x is very, very near to 0, that line will not be a tangent anymore. So whatever the slope of that line, sorry, what I've told, man, I've told opposite. Under the circumstance when delta x is very, very small, that line will not be a secant anymore. That is going to become a tangent. And this expression was giving us the slope of that line, who is tangent now. So will be called as what? Slope of the tangent or not? Correct? So that expression same only. This expression is giving me the slope of that line, AB, a slope of the secant AB. But when delta x very, very small, that line is not secant anymore. It has become tangent at A. So this expression, what it must give us? Slope of the tangent to the curve or not at that point. And slope of the tangent is defined as the slope of the curve. And this thing So whatever the value of this expression will be coming out to be equal to. Okay. How to find the limit value? You don't have to. You have to mug up formulas for it. So however you find what it is giving us, slope of the tangent, and that is same as the slope of the curve, and that thing is given a name dy by dx. That is called as derivative or differentiation of y with respect to x. Also got a name, it has got a name. We'll discuss why such names are also there. Rate of change of y with respect to x. So whatever done on this slide, is it clear to everyone or not? That clear, no? Okay, then good. I'll take a new page. So dy by dx is defined like this, and it is giving us something which is slope of the curve. So there's a book I will share with you. It is called Calculus for Dummies. So you read this book also, in case if you have some confusion still underlying. So what all things you will read? This one only. This part you will read. So okay, I'll mark it later on. So another way to look at this thing is, so read these things. Maybe it might be of useful in understanding it in more better way. So up till here it is clear to everyone. There's one more way to look at it. But before that, I tell you some math notation. Somewhere we write delta x, we understand it means finite change in x. Somewhere if I write dx, it means change in x only. See, instead of delta, this triangle symbol, I'm writing d. We pronounce it as dx. Dx written means I'm talking about a change in x. But it will be a very, very, very tiny change in x. Or the correct word for that is infinitesimally small change in x. And what is this? So you can write like this: dx is infinitesimally small change in x. But maybe I don't want to use much language. Maybe I want this thing to be understood by a Russian guy also. So what dx means? Delta x only, change in x only. But what kind of change in x? Which is very, very small. Dy means change in y only. But what kind of change in y? The one which is very, very small. So I can write this thing, that limit delta y tending to 0, delta y means dy. Or maybe you don't want to write down using symbols, you can write like this also. It means a change in y which is infinitesimally small change in y. There's another way to look at this thing is, suppose I want to find slope of the curve at any place, okay? Suppose that point is x equals to, suppose 3 or whatever, suppose x equals to 3. Then I'm going to do a tiny, tiny change in x. See, I'm drawing it big, but the change in x is so small, no man, that you can't see it even. So here x will be x plus dx. In case for understanding purpose, I took x as 3. So it will be 3 plus dx. Now, these 2 points are like almost 1 point only. Here I have x to be x plus dx. So because of that, I move from point P to Q on this curve. Now, since point A and B are like point P and Q are like almost 1 point. If I drop a line to pass through P, it will end up almost passing through Q also. So now we have done dx change in x. Due to that, so what we have done this much change in dx, which I have drawn with black color. And that is dx. And due to this much change in x, we undergo this much change in y, which I have drawn with violet color. Now, how small this PQ is? It is as small like a dot, literally like a dot. And if something which is as small like a dot, I can call him as a straight line also, as a curved line also. Both are correct. So for example, if that is confusing thing, I will tell you. See, circle or a curved length is made out of dots, and a straight length is also made out of dots. So if I take a dot from this curved length, and if I take a dot from this straight length, both the dots will be identical or not? Without showing you from which thing I have taken that dot, from this curved one I have taken a dot, from a straight one I have taken a dot. You can't recognize, no, whose dot it is. Like it is like mathematical building block of the curve, no? Like if I take a carbon atom from the body of Chinese person, a carbon atom from the body of Indian person, can you tell whose carbon atom it is, Chinese one or Indian one? You can't tell, no? Because those are biological building blocks, they will be identical. Same way, something as tiny as a dot is a building block of a circle also, is a building block of a straight line also. So something as tiny as a dot can be called both straight line also, a curved line also. Both are correct. So which one we call, that depends upon what is the thing which will give us easy mass, or what is the thing which will be fulfilling some purpose. Okay, so this PQ, now at point P, the output will be whatever output I have at input 3, or maybe I'll write in general X. At point Q, what is the output will be? Whatever the output I have when the input is X plus dx. So change in output due to how much change in input? Due to dx change in input will be equal to how much? F of x plus dx minus of f of x. And that will be a change in the y, or the output, which is a tiny change. So how we write tiny change as dy? So in that triangle PQR, you will find, in this triangle PQR, you will find QR length will be dy, which is f of x plus dx minus f of x. And in that triangle PQR, see, I can say PQR is a triangle because I can totally consider PQ like a straight line even though it is not. because how small PQ is. So small like a dot, like a virus. Something so small can be called as a curved line, can be called as a straight line. But if I call him as a straight line, I can think PQ are like a triangle. Then this angle theta, then this angle also theta. Then the slope of the tangent will be tan theta. And what tan theta will be? QR by PR. And what is QR? dy. And what is PR? dx. So that is another way to understand what dy by dx is. So maybe I'll write that thing again. What dy by dx is? F of x plus dx minus f of x by dx. That is like informal way to write this thing. Formal way to write this thing will be what dx means delta x only, the one which is very, very small. So I can write him down as delta x tending to 0, f of x plus delta x minus of f of x by delta x. I hope this way all of you have understood. All of you have understood, no? I'm telling it in like most proper way that you have to understand. And most proper way will be difficult way. Maybe I will tell it tomorrow, today, tomorrow you will understand, no problem. Tomorrow you understand, but you must understand it properly. Maybe in 12th class you understand, no problem still. But all of you have understood it or not? Anyone having any confusion? It will be confusing, I know. But still somewhat you are making sense of out of these things.
It's clear, sir.
Clear than good. Clear than man, your brain, people brain is like good. Okay, so I will take a new page now. So I'm going to write something in informal way, but it is very useful thing to know. So you must be treating whatever method I use to find dy by dx, but you should not forget what it is. It is like some ratio like p by q only, where something is there in numerator, something is there in denominator. So it is ratio of change in output. See what really numerator contains. Change in output. What kind of change in output? Suppose it depends where I want to find this dy by dx thingy. I want to find out this guy at x equals to 3. So I'm going to do a very, very small change in the x from 3 to 3.00000001. In doing that tiny amount of change in x, by whatever amount y changes by, somehow we measure it. Don't get into that thought process how I will find such a small change in such change in y when the change in x is so small. Don't worry about that. Somehow if you can find, then place that change in the output and divide it with the change in the input, which is very, very tiny. That will be giving us whatever this thing is, which is called as dy by dx. So dy by dx, however you find, God comes and tells you the dy by dx result of some function, no problem. You have marked up some formulas to find dy by dx of some function, no problem. Whatever method you use to find dy by dx, don't confuse that with the fact that it is ratio of change in output, that is y, and change in input, that is x. When the change in input, that is x, is very, very small, or it is infinitesimally small. This is an important point to understand. So it is a ratio of change in output, that is y, and change in input, that is x. When the change in input, which is x, is very, very, very small. So we place that, so we do a change in the x, which is very, very small. So we change x from, suppose x to x plus tx. Due to this change in the x, suppose the y changes from y to y plus dy. So somehow we measure the change in the y, and we know what change in x we have done. So placing that dy in numerator and that dx in the denominator will give us something which we call it as dy by dx. Do you want me to repeat any of this? Or I'll give a second or two to understand it. I'll take a new page then. So understanding part over, I will be telling formulas that we have to use to do differentiation. Just I will derive one or two formulae, that's all. Because if I derive all, it's going to become math class, then what master will do? Okay, I can take a new page. I can take a new page now.
Yes, sir.
Okay. Now I will take a very basic kind of function, but famous function. His name is identity function. And what is this function is? F of x is equal to x, or y equals f of x is equal to x. So y identity function, you got the reason why that name it is having. Output y is same as input x. And the graph of that function is a straight line passing through origin and making an angle of 45 degrees with positive x. So slope of this line is equal to tan 45, and that is 1. So straight line is a curve only. So you can't say, sir, how straight line is a curve? It is a straight line. No. Straight line is a curve which is straight. We can say totally. So straight line is a curve. Curve means plot or graph. Okay. Curve does not means it is curved line always. So straight line is a curve whose slope is same everywhere. And this straight line has slope which is equal to 1. And the symbol we use for slope is also m. Now, I know its slope. Now I will use this method, which is finding dy by dx of a function to find its slope, just to satisfy ourselves that whatever this mumbo jumbo we have talked about, whether really it works or not. So it is like purely a little bit mind-bending kind of thing also. So what is dy by dx of this function will be limit delta x tending to 0. See, this is not the way you will be ever doing differentiation. Never. Just to tell you from where all those formulas came from, the one that you have to mug up. So this is the dy by dx of any function is. So what is the job this function does, man? When I give him x, he gives me x. So when I give him f of x plus delta x, what is the answer you expect from him? Output same as input, so x plus delta x only. So it is going to be limit delta x tending to 0. So what will be replacing f of x plus delta x? That will be x plus delta x. What will be replacing f of x? That is x divided by delta x. How to solve limit of anything? You plug the limit value to check first what answer comes. So we will do that. I will plug the limit value where delta x is 0. What I get is x plus 0 minus x by 0. x gone, it became 0 by 0. Means undefined, means more solving required. What solving? See, solving or simplification thing is not something difficult. So limit delta x tending to 0, I can cancel this x with that x. So one simplification done. After this simplification, we end up with delta x by delta x. Now, again, if I plug the or insert the limit value, we get 0 by 0 undefined. So on using delta x as 0, it becomes 0 by 0 undefined, means more solving required. What solving we will do? As we understand, this delta x is not 0. Just it is very, very small. So small or big, if the things in numerator and denominator are equal, I can cancel them. So I cancel that delta x with this delta x. So what it becomes afterwards is limit delta x tending to 0, 1. So nothing to insert where delta x value to be 0. So 1 is our answer. It means dy by dx of y equals to x is 1. And what is the slope of this thing is 1. So means this dy by dx, whatever this algorithm is, it is giving me the slope of the curve. So it is something true only, not something which doesn't work. It works. So whatever the reason it works, but it works. I hope this thing all of you have understood. But you don't have to understand this. You have to know somehow I do this dy by dx, I get 1. I'll be telling some formulas for it. I can take a new page now.
Yes, sir.
Okay, then now I will draw a curve which is a famous one called as parabola. And it is a curve like this. And it is y equals x square. Now here, see, even though we cannot tell what is the slope of the, not looking nice, just a moment. Sometimes I try to be perfectionist, it is not good. Okay, this is the curve y equals x square. Suppose if I tell you, check out a point somewhere in the first quadrant and determine what is the sign of the slope will be positive or negative. So if you don't know this trigonometry thing, if theta is acute, then tan theta is positive. When theta is obtuse, tan theta is negative. So if I select a point somewhere in the first quadrant where totally you know x will be more than 0, and roughly I drop a tangent somewhere, everywhere in first quadrant you will realize that where x is more than 0, theta is going to be something acute only. So the slope of the curve will be positive since slope is equal to tan of the angle theta made by the tangent. So slope positive. Now next is, suppose if I drop a tangent at x equals to 0, which is the origin. So here at x equals to 0, the tangent is making what angle? It is making 0 angle. So at x0, the slope is 0. Now I take another point somewhere in the second quadrant, where any point I select in second quadrant, you will get value of the x to be negative. And there you will find the angle made by the tangent with positive x direction it is obtuse. So slope, which is tan theta, is negative. So three things I know with guarantee: that when x is negative, slope is negative. When x is 0, slope is 0. When x is positive, slope is positive. So whether same outcome we get by doing dy by dx thing or not, we are going to check just for our satisfaction. So how to find dy by dx of this function? What is this function is? Y equals f of x equals x square. What is the job it does? On giving an input, it is going to square it up. That's all, no? So his dy by dx, same thing, it is going to be right here. It's going to be limit delta x tending to 0, f of x plus delta x minus of f of x divided by delta x. So when I give him x, it gives me x square. So when I give him f of x plus delta x, what answer you expect? So it is going to give us x plus delta x square. So this is going to become limit delta x tending to 0, x plus delta x square minus of x square by delta x. Now, I will plug the delta x 0 to check what answer comes. It will be x square minus x square by 0. That is 0 by 0 means undefined, means more solving required. What solving? Nothing difficult. You use a plus b whole square formula. It will become x square plus delta x square plus 2x delta x minus of x square by delta x. What solving we can do? I can cancel this x square, this x square. After every simplification, we will plug the limit value. So it is delta x square plus 2x delta x by delta x. So right now, if I plug delta x as 0, we get 0 square plus 0 by 0, which is 0 by 0. Means more solving required. What solving we will do? We will take delta x common in numerator. We get delta x plus 2x by delta x. Now totally I can cancel this delta x, this delta x. We get limit delta x tending to 0, delta x plus 2x. Now if I put delta x as 0, what answer we get? 2x, which is totally defined. It means dy by dx of this thing is 2x. So dy by dx of this thing is 2x. What it means? That his slope is equal to 2x. Now, is it not satisfying the thing that we know already? When x is 0, what is the slope is? 0. When x is less than 0, what is the slope is? Less than 0. When x is more than 0, what is the slope is? More than 0. It means it looks like that dy by dx most is correct, that it is giving us the slope of the curve. And also we got to know that when y is equal to x square, the dy by dx of this guy is 2x. I hope whatever done on this slide is clear to everyone.
Yes.
I hope it is not becoming unbearable to anyone, no? If it is becoming unbearable, don't worry. You don't skip every step. Somehow you have to know that, okay, dy by dx of x square is 2x. How? Don't worry about that. Got it, no? From here to here, what steps we have followed, you don't have to know. For doing physics, you have to know that dy by dx of x square is somehow 2x. If you know it, good. If not, not a problem at all. I'll give a minute, maybe 30 seconds to digest all this thing. Then I will take a new slide. Okay, I can take a new page. I can take a new page, Naman. People left, man. Again, this backup cannot happen again, man, because to understand the running things in the class, maybe you have to understand these things as soon as possible. Okay, I can take a new page now. Okay, then. So what we have got till now is, for y equals to x, I get dy by dx as 1. So for y equals x square, I get dy by dx as 2x. So same process if I follow, we don't have that much time, so just I'm telling it like a fact. And you don't have to know also. Even we had time, you don't have to know that much. So dy by dx is going to be 3x square. Then next, if I figure out for x power 4, we get dy by dx to be equal to 4x cube. Now there's a pattern emerging or not? That if I had x power n, what formula of dy by dx will be? So here I was having 4. So I got 4. Power of x was 4 reduced by 1. His power is 3 multiplied by 3, power reduced by 1. Same pattern here also. Here x has what power? 1. So what we have done really, we have multiplied x with 1 and we have reduced his power by 1. So that is giving us 1 into x power 0, and 1 into x power 0 is 1 only. It means x power n differentiation will be n into x power n minus 1. I hope this thing is clear. Now, the final thing and all difficult thing over after this. Here, what is y? That is x. And its dy by dx is 1. Here, what is y? That is x square. Its dy by dx is 2x. So here what is y really? X. So x is given a new name, no y. But when we use y, what really I'm talking about is x. In this case, if I use y, what really I'm talking about is x square. Here, if I use x, y as x cube, when I write y, what we are talking about, x cube. So instead of calling x with different name, I can write y whatever it is. That dy by dx of x will be 1. So whatever y is, I'm replacing it with that. Dy by dx of x square is 2x. Whatever y is, I'm replacing it with that. Dy by dx of x cube is 3x square. Dy by dx of x power 4 is 4x cube. Dy by dx of x power n is n into x power n minus 1. Now, I will talk about something like if I write a plus b, what is plus coming in there and telling us? So plus is a mathematical operator that comes to tell us that we have to do the operation of addition. So same way from now on, somewhere if I write dy by dx, inside something is given inside this bracket. So that can be x square, that can be x cube, that can be x power 4, that can be x power 1, x power n. What it will be doing to whatever given to him, it will be finding out the value of this thing of that given thing, no? So from now on, we'll be using it like an operator. So it is an operator. What it does, it is going to find differentiation or derivative or rate of change with respect to x. So up till here, it is clear to everyone. Now I will be telling the formulas that you have to remember. Okay, I can take a new page.
Yes, sir.
And this table you have to remember for whole life. Okay, not for like 11, 12th only. In first column, I'm writing f of x. In second column, I'm writing the differentiation of that f of x. So this one, you try to prove it on your own. That for a constant function, its differentiation will be 0, homework. X power n will be n into x power n minus 1. Sin x will be cos x. Cos x will be minus sin x. Tan x will be secant square x. Secant x differentiation will be secant x into tan x. Cot x differentiation will be minus cosecant square x. Cosecant x differentiation will be minus of cos. Every time in class, one time the series will come. Minus of cosecant x into cot x. Then e power x. I hope you know e power x, no? That log e. If you don't know, maybe we'll talk about later on. It will be e power x. A power x differentiation will be a power x divided by log EA. E is Euler's number. So it is the natural log of A. So this, and finally one more, ln x, or shortcut way to write log ex. In physics, sometime I write log x, not mentioning what base it has, means it is e. All this has differentiation 1 by x. So if you can't remember all, but this one, this one, this one, this one, this one, this one, this one. This one at least you should not forget. Okay. The one that I have marked. Okay. Now one more table I'll give. I'll be proving the other table. But that is like I can take a new page.
Yes, sir.
Suppose if I have a function f of x, which is sin x. So input here is x, no? So we get sin x. So now if I write sine of 3x plus 5, you get the meaning, no? Here the input is x, but what is the total angle that is given to sine function is 3x plus 5. Okay. So what is the difference between sine x and sine 3x plus 5 is? Here, in this case, the input is x and the argument of the function. Argument of the function means what is the value which really affects the function is x only. Here input x only, but just the x value is not affecting it. What is really goes inside sine function is 3x plus 5. So I'll say the argument of this function is 3x plus 5. I hope you get the meaning of what is the argument of a function and what is input is. Now, if I give you this table, I have ax plus b to the power n sine ax plus b, where a and b are some constants, cos ax plus b, tan ax plus b, secant ax plus b, cot ax plus b, cosecant ax plus b, and e power ax plus b log ax plus b. So differentiation of c, if I had x power n, I get n into x power n minus 1. The thing that is taking the place of x now is ax plus b. So if you know that old table, you can get answer for this table also. So what was done with x, same thing will be done whatever comes in the place of x. What is coming in place of x now? Ax plus b. So what was done to the x? He was multiplied with his power and his power was reduced by 1. Same thing done to him. But extra thing that we do is to multiply by a, which is the coefficient of x. So if it was sine x, what was the differentiation? Cos x. So sine ax plus b differentiation will be cos ax plus b multiplied by a. If it was cos x, its differentiation was minus sine x. So its differentiation will be minus a sine ax plus b. Secant x differentiation, tan x was secant square x. So tan ax plus b will be secant square ax plus b. Extra thing, multiply by a. Secant x differentiation was secant x into tan x. So secant ax plus b differentiation will be, you write down, I will write this one. E power ax is e power x. Nice guy, nothing to remember. So e power ax plus b will be e power ax plus b multiplied by a. Log x is going to give us 1 reciprocal of x. So log of ax plus b will give us reciprocal of ax plus b, just multiplied by a. So a by ax plus b. So rarely you will use other formulas. Your life in physics will be revolving around this only, mostly. Okay. Rarely you will use any other formulas except 1, 2, 3, 4, 5, 6. Okay, maybe even not this one. So 99.99% time, 1, 2, 3, 4, 5 formula physics over, man. Okay. That for safety I've told, others you write down on your own. So we can prove these things. Once I tell you what is chain rule, you can do this thing orally in your head also. So that we'll be seeing in next class. But even though we'll not be using chain rule, rarely we'll use, but we must know what chain rule is for other purpose, not for maybe differentiation purpose. So this much all of you have understood. No problem, no one. Understood, no? Abhinaya, Rishi, Karthik. Understood, no? Understood, no one?
Yes, sir.
Okay, then. See, my shift, my class started at 9. So my shift got over at 5:30 only. But I'm taking this class in my extra time. Because I don't have any time left to take backup class, man. So when I'll tell backup, please join because we don't have much time left. Okay, then, so maybe you must have been tired also. So main thing of differentiation over, after whatever it is simple algorithmic things. So technically, properly, it will take at least 2 more classes to finish everything of basic calculus. But maybe I will try to finish it in one more class tomorrow, 7:15 to 9, like this only. Okay. I will post the timing in case if something changes before 12:30 p.m. tomorrow. Okay. Okay, then bye everyone. I'll post this thing in our group also.
Bye, sir. Thank you, sir.
Bye. Bye.
Sir, bye, sir.
Bye.